Alright, so today we're going to talk about how to solve an equation that has more than one variable in it. Now, these are not systems of equations where we have two or more equations for two or more variables. Here we only have one equation, more than one variable. We want to isolate one of those variables. So the key is to pretend that all the other variables you aren't on for are just regular numbers and move them around as you would as anything else we've done in this chapter. That's the key for these problems. So, to solve each equation for the indicated variable, we have 9z plus 5b equals 2z. We want to solve for z. So here's my equation, 9z plus 5b equals 2z. So if I want to solve for z, I need to combine all my z's. Well, 2z is already isolated on this side. Let's subtract 9z from both sides. We get 5b equals a negative 7z. Now again, I want to solve for z. So if this was an equation like 12 equals negative 7z, you just divide by negative 7. So let's just divide by negative 7. We get a negative 5/7 b equals z. And that's it. These are the exact same types of equations we've been dealing with, where the 5b, we're just going to pretend it's a number. I can't combine it with anything because there's no other b's, but I also don't want to combine it with z. So I leave it alone, combine my z's, and isolate the z itself. So 4m minus 3n equals 8. I want to solve for m. Well, here's my equation. I don't have any other m's in the problem to isolate, so I'm going to leave 4m here. I need to move the negative 3n. I move it by adding. So 4m equals, now you can't combine 8 and 3n. One is a variable, one is a number, so they have to stay separate. You should write the variable before the number, so it's 3n plus 8. And then to solve for m, well, we would have to divide by 4. So what we're going to do is divide each and every piece by 4. So 3 over 4 is just 3/4 n. 8 divided by 4 is 2. So m equals 3/4 n plus 2. So yeah, we can't combine variables with numbers. They have to stay separate. So make sure you keep their signs the same. And I need to divide each and every piece by the number in front of the variable I want to solve for. That way I can reduce it as far as possible. That's why it's 3/4 n plus 2. Now 28 equals a times b plus 4. Now I want to solve for a. Well, if this was just my equation, 28 equals 7a, you would just divide by 7. So here, I don't want to distribute a into the b and the 4. That's not going to make my life any easier because I would usually not be able to combine the a, b with the 4a. So instead, we're just going to divide both sides by the expression b plus 4. If b plus 4 was 7, that's exactly what we would do. Since this is an expression, I can't divide it and simplify it any further. So just 28 over b plus 4 equals a. Straightforward and simple. Now this one's a little bit different because since we have x times quantity of y minus 8 equals 23, but this time I want to solve for y. I want the variable that's inside this expression. Now, to solve for y, you have two different options the way you can do this. We can distribute the x inside first and then move around to solve for y, or I can divide by x first to solve for y. The easiest thing I would find to do for this particular problem is divide by x. Don't try and confuse yourself by distributing a variable into another variable if you can avoid it. By dividing by x, they cancel nicely, leaving y minus 8 equals 23 over x. Now to solve for y, it's all by itself here. I need to move the negative 8. We're going to add 8 to both sides. And I can't combine 8 with the 23 over x, so that stays 23 over x plus 8. The other way you could have solved, like I said, you could distribute the x into the problem. Then you get xy minus 8x equals 23. To solve for y, you'd have to add the 8x to both sides. Xy equals equals 8x plus 23. And then divide each piece by that x. So y would equal x's cancel, 8 plus 23 over x. As you can see, it's the exact same answer, so it doesn't matter which way you solved it, you'll get the same exact answer. So it's your choice. I personally, as I said, I would like to divide by the variable first and not worry about distributing it. Honestly, it makes the problem a little bit quicker. But distributing the x in first and then solving, perfectly acceptable. There's no reason why you can't do that. So why don't you go ahead and give this one a shot on your own. You want to solve for k. So we need to isolate it by getting rid of the 5 and the negative 2. So go ahead and try and do that on your own. Alright, you should be getting for your answer, k is going to work out to be 55j plus 2. And what you should have done is you should have multiplied both sides by 5 first to clear out the fraction, leaving it k minus 2 equals 55j. And then just adding 2 to both sides. That gets you the answer you want. How about this one? Do this and solve this one also. You want to solve for x. So you want to get this one all isolated, so move the y, and then get rid of the 5/6. Alright, if you do this properly, you should find x will equal 6/5 of z minus 6/5 of y. You have a couple different choices to solve this. Probably the easiest thing to do is subtract y first. You can get 5/6x equals z minus y. And then multiply both sides by 6/5. The reciprocal to get rid of the 5/6, and that's how we get 6/5 z minus 6/5 y. 6/5. There we go. Now here's where it gets a little interesting. We have this equation, 2x minus 2y equals xz plus 5. And I want to solve for x. So the key for all these equations to solve for the variable is to move the variable to one side and combine like terms. So I've got a 3x here and an xz over here. So let's subtract xz from both sides to bring all the x's onto the left-hand side. Now, these are not the exact same expressions. Yes, they both have an x, but I can't combine them because 3 and z are both different. This is 3x minus xz minus 2y equals 5. So I should add 2y to both sides to again further isolate my x expression. So 3x minus xz equals 2y plus 5. Now, how do I solve for x if I can't combine them? What we're going to do now is we're going to do what we call reverse distributing. If I had this expression, x times 4 plus a, and I distributed it the x, we'd have 4x plus ax. So that's what we're going to do in this case. We're going to now reverse that process. We notice they both have an x in common. So I'm going to factor it out. And if I divide this by x, what's left over? 3. Divide this by x, what's left over? Negative z. So that's what we call factoring. We take what they have in common in x, take it outside the expression, leaving only an expression that does not have x. Now in order to solve for x, we divide by 3 minus z. And we get x equals 2y plus 5 over, I'll rewrite properly, negative z plus 3, the variable before the number. So there'll be some problems where you're required to factor because you cannot combine your variables in any way. There's no way to combine 3x and xz. The only way to do it is to factor out the x, what they have in common, and then solve from there. That's what you can do on this problem. We're going to solve for a. So do what we just talked about. You're going to do this on your own. You're going to bring the a's over to the same side, left or right, doesn't matter. And then you're going to factor the a out of there so you can solve for a. Okay, so you should be getting for your answer a will equal c plus 18 over b plus 6. Again, if you move things around, move the ab to the left, the 18 to the right, you have 6a plus ab equals c plus 18. They both have the a in common, that's where you can factor it out, leaving a 6 and a b. And that's how we are able to get this equation right here. Alright, so that's solving for an indicated variable in an equation that has more than one variable. This is a very important tool, especially when you have formulas in your science classes, where you have multiple variables in your formulas, or your geometry formulas you're going to deal with in a future class. This allows you to, before plugging anything in, rearrange the equation to solve for one variable. Next time, this is the end of Chapter 2. So next time we're going to talk about how to graph equations of lines.